Right.
Okay, so my name is Olafur Jonasson, and I'm going to talk about the status of NOAA ACSPO SST products. So I'm talking on behalf of the NOAA Star SST group, led by Alexander Ignatov, and here are all the other members. So this is a short overview of what we've been up to for the last year or so. So we have 3 new satellite launches, so NOAA 21, GHOST 18, and Himawari 9. And we also performed the first NOAA MODIS reanalysis, so MODIS Run 1. And we also have a new L3S LEO version 2.81 release, which includes NOAA 21 and MODIS and Aqua and mitigates some SST anomalies. So we also have some improvements to ICOM quality control, and we'll end with some future priorities. So JPS2 was launched on 3rd of November of 2022. So when it was renamed NOAA 21 or N21 after successful launch. So it's the same afternoon PM orbit from 1:30 AM PM as NBP and NOAA 20, and it's currently NOAA 20 is currently a quarter orbit ahead of NBP and a quarter orbit behind NOAA 20. However, when NOAA 20 after NOAA 21 is declared primary, NOAA 20 will be moved ahead a quarter orbit. So this will be the planned constellation shown in this picture on the lower right. So the cryocooler door opened on February 8th, and the NOAA 21 SST was declared provisional on September 1st, so it then was open to users. So high-quality NOAA 21 SST is currently available back to March 19 on NOAA CoastWatch, and we're working with PODAC to archive, and we're also planning to archive with NOAA NCEI. So this is produced with the NOAA same ACSPO version 2.8 as NP and NOAA 20, and it's consistent with those products. So these time series show the time series of accuracy and precision for the subskin and depth SST from all 3 virus sensors. So you see MPP going back to 2012 and NOAA 20 launched in 2018, and here in green is the NOAA 21 SST. So you can see that the accuracy and the standard deviation or precision is very comparable to the previous 2 virus instruments. So we also have we have a new GHOST West G18. So it was launched on March 1st, 2022. So it was renamed GHOST 18 after successful launch. So it's initially placed in GHOST 16, between GHOST 16 East and GHOST 17 West. And in between May of June of last year, it was transitioned to its permanent West position. So the L1B data from G18 or West is available from June 7th and on, and G18 was declared operational, or G18 SST was, the satellite was declared operational at GHOST West on January 4th, 2023, replacing G17. So the ACSPO version 2.90 SST for G18 became available in July of 2023 in PODAC, in CoastWatch and NCEI. So switching from GHOST West to GHOST 18 provided a significant improvement in SST quality because of the G17 heat pipe issue. So the G18 API instrument works as intended, and the images on the right compare the G17 and G18 nighttime SST minus CMC level for the foundation SST for 1 day. So you can see on the left there's lower coverage by G18 because of the heat pipe issue, and on the right is G18 with more coverage and also less pronounced biases. So G18 is supported for all 24 hours, with only 13 for G17 because of the heat pipe issue. So Himawari 9 replaced Himawari 9, and Himawari 9 replaced Himawari 8. So Himawari 9 was launched a while ago in November 2016, and it reached orbit on over 140.7 east on November of 2016. However, it's been in standby mode until September of last year. So starting October 22, 2022, the Himawari 9 L1B data became available for NOAA, and Himawari 8 was switched off in December of last year. So ACSPO version 2.90 SST for Himawari 9 became available in July 2023. So it's available in CoastWatch, PODAC, and NCEI. So the Himawari 8 and Himawari 9 AHI sensors have very similar performance. So improvements come in the form of, like, we updated from version 2.70 for Himawari 8 to ACSPO in version 2.90 for Himawari 9. So the improvement includes improvements in the cloud mask or the clear sky mask. So you can see here in the top, the red rectangles, you can see that we have much better coverage in dynamic regions now in the 2.90 results. And also the black curve, so the thermal front, which is a new product that started in 2.80. So we're now currently working on reprocessing the full HIMORI 8 record from 2015 to 2020, so to make these two satellites, the SST and product consistent between those two. So we performed the first MODIS reanalysis, or first NOAA MODIS reanalysis, or RAN1. So this includes Terra and Aqua. So the main motivation was to extend the L3S LEO PM record back to 2002, which is the earliest Aqua SST, and L3S LEO daily to 2000, which is the earliest Terra SST. So the NOAA and RAN1 in a dataset has various improvements over existing NASA R2019 dataset. So we have worked on to fix artifacts or mitigate artifacts in a modest thermal emissive bands. So they include the Terra 0.1 Kelvin SST anomalies during quarterly warm-up cool-down exercises. So this is when the black body temperatures varied over the course of a few days. So this is approximately quarterly. So here the top figure shows the time series of daily mean bias versus CMC level 4 in an SST. So you can see the spikes in bias in nighttime SST. So these are warm-up cool-down events. So you can see them in with ACSPO without any mitigation, and here red is with mitigation. So you can see that we have successfully mitigated the biases. So we also have residual 0.05 Kelvin drift of Aqua and Terra SSTs over the course of the 20-year mission. So you can see the time series of accuracy versus in situ drifter SST. And so you can see that on the right here is like the same results, but with the mitigation of the drift in brightness temperature. So you can see it's now much more consistent in time, now much more flat in time, the time series of bias. And for comparison, the R2019 dataset from NASA is also shown here. So we also mitigated various steps in Terra SST due to changes in MODIS configuration. So the entire MODIS RAN1 L3C data is available currently on CoastWatch, but we'll be looking into archiving L2P, L3U, and also L3C we'll discuss that with Porak. So we point you to the GHRSST poster for more details. So we also have a new global 0.02 degree L3S LEO update to version 2.81. So we have the L3S LEO PM product. So this is SST from afternoon PM orbit satellites. So this is reported twice per 24 hours separately for day and night. So version 2.80 included only NPP and NOAA-20 VIRS. However, in version 2.81, we're adding NOAA-21 VIRS, and we're also adding MODIS Aqua. So this will extend the PM record back to 2002. We also addressed the residual drift in VIRS daytime SST. And as for the L3S LEO daily product, so this product includes all available ACSPO high resolution SST from LEO sensors. So this is both day and nighttime data in one file per 24 hours. So in version 2.80, we included MATOP APC, AVHR FRAC, and NPP and NOAA-20 VIRS. So in 2.81, the updates we've added NOAA-21, Aqua, and Terra. So this extends the L3S LEO daily records from 2006, so as the earliest MATOP A, back to 2000, earliest Terra SST. So you can see here, like the top figure shows the version, the clear sky ratio in version 2.80 and 2.81. So that's the fraction, clear sky ratio is the fraction of clear sky global pixels or ocean pixels. So you can see in 2.81, we now can go back to 2000 for L3S LEO daily with Terra. And another improvement is that the PM product, which is red here, is extended back to 2002 in Aqua lens. And also, we also have just more higher clear sky ratio because of the extra sensors. So the L3S LEO 2.81 is currently available on NOAA CoastWatch, and we're working now with Porak, or we're planning to work with Porak to archive it there. So currently, we only have version 2.80 archived at Porak, and it's also archived at NCI. So we also have planned IQUAM improvements. So the NOAA In Situ SST Quality Monitor, or IQUAM, is an online system that collects in situ SSTs from various sources. It performs quality control, or QC, and it provides data to users. So the current IQUAM version 2.1 QC strongly relies on comparison to individual in situ SST at foundation level for SST analysis. So this causes overscreening areas with strong diurnal warming and dynamic regions. So the newly developed diurnal reference check, or DRC, mitigates this overscreening by considering like a time series, so 24-hour time series of the drifters and mooring data instead of just instant values. So these figures are a comparison of IQUAM 2.1 top figure and the proposed new check. So you can see the black is the dots are in situ measurements that are falsely or overscreened because they are strong diurnal signal, which is fixed in the new version. So we're currently working to implement this in a new IPAM release. So as for near-term priorities, so the first EUMETSAT Meteosat 3rd Gen or MTG will be launched, was launched in December 13th. So EUMETSAT L1B data delivery to NOAA currently planned for October 2023 earliest, and NOAA will generate MTG FCI SST product using ACSPO. So there's also the EUMETSAT METOP 2nd generation or METOP SG, that's a LEO satellite. So the launch is currently planned for March 2025. So we'll get, and this will continue the METOP 1st generation in mid-morning, 9:30 a.m. PM orbit. So we also plan to generate a METOP 2nd generation SST using ACSPO, and we will also plan to include it in the LTS LEO AM product. So we're also going to work on the LTS LEO GEO line of products. So this will be created LTS LEO GEO, so super collated product from geostationary satellites. So this will include G16, 17, 18, HIMAWARI 8, and 9, and eventually MTG. So we plan to reprocess all GEO SSTs, so we process G16 and HIMAWARI records using ACSPO version 2.90 and archive it goes towards the PODAC. And we'll also be working towards ACSPO version 3.0, which propagates recent GEO improvements to LEO sensors. And we have a planned release for summer or fall 2024. Yeah, that's it.